Children, in this video we are going to start one more new chapter, that is polynomials. Before going to start this chapter, you should be knowing some basic things about these polynomials and what you have studied already in 8th standard. In 8th standard you have studied one chapter, that is algebraic expression. In that chapter you learned addition, subtraction, division and multiplication of algebraic expressions, and you learned how to factorize the algebraic expressions by 3 methods. Those are by taking common factor is the first method, by grouping is the second method, by using identities. Identities means a plus b whole square formula. You learnt a plus b whole square formula is a square plus b square plus 2ab, and a minus b whole square formula is a square plus b square minus 2ab, and one more formula you've learnt, that is a square minus b square is a plus b into a minus b. Using these identities we factorize the algebraic expressions. And you learnt one more formula, that is x plus a and x plus b. This also you learnt. These 3 formulas are very important, and including these formulas in polynomial chapter, some more formulas you are going to learn, and you learnt about the polynomials also. First, before going to start the polynomial definition, we will see what is algebraic expression. If you want to learn the algebraic expression, you should see variable, constants and the terms and all those things. Just I will revise what are the basic things you learnt about the algebraic expression, then we will go for the definition of the polynomials here. So what is the meaning of the variable? Variable is a symbol that can take any real values. For example, we can represent the variables by the alphabets. Especially we will use the letters x, y, z for the variables. We can use p, q also. Most of the times we will use for variables x, y, z, p, q also we can use it. So here in the place of variable, any real value we can replace it. X may be 1, 2, 3, 4. The symbol which can change the value is called as a variable. This already you know it. Next you learnt about the constant. Constant is a symbol which cannot change the value. For example, for the constants are numbers 1, 2, 3. These are the numbers for the examples for the constants. And sometimes constants also we will use. Constants also we will represent by the alphabets. If you want to represent the constants by alphabets, means we will use the letters A, B, C. Just you remember, always to represent the variables we will use the alphabets. But sometimes in the polynomial chapter, we are in place of constants also we are going to use the alphabets. If you want to represent the constants as alphabets, means constants, if you want to represent the alphabets, means you have to use A, B, C for the constants. You can use A, B, C, D also. And if in the algebraic expression, if they used in place of constant as alphabets, means they will mention there. For example, I will show you one expression they will take. For example, like this, ax plus b. This is algebraic expression where a and b are constants. Like this, they will mention there particularly. If they used the alphabets for the constant, means they will mention there where a and b are the constant, like this. Here x is a variable, a and b are the constants. X, y, z we will use for the variables. And you know that algebraic expression is a combination of constants and variables and different operations of mathematics, means plus, minus, into, division we will use there. And you know how to separate the terms. Always terms are separated by the plus or minus symbol. You know that. Here in this expression, how many terms are there? 2 terms, because here plus is separate. Always if you want to separate the terms, plus or minus should be there. Here 2xy is there. Here how many terms are there? Only 1 term is there, because multiplication and division will not separate the terms. Suppose if I write 2 plus xy, here 2 terms are there. 2 plus x plus y, if I write 3 terms are there here, because 1, 2, 3. Here it is only one term. 2 plus x plus y means 3 terms. Here 2 terms. Always if I write like this, x plus y here also, this is also only one term. Division will not separate the terms. Based on the number of terms, you learned if an algebraic expression is containing one term means that is called as a monomial. If algebraic expression is containing two terms means that is called as a binomial. If algebraic expression is containing three terms, trinomial. Like that we will call them. Otherwise, algebraic expression containing four terms means it is not having any name for it. Don't get confused, it is called as a polynomial. An algebraic expression containing four terms means this is called as a algebraic expression with the four terms. It is not called as a polynomial. Don't get confused. Polynomial is a algebraic expression. I will just show you the definition. What is the definition of an polynomial? An algebraic expression with a whole number as an exponent of the variable is called as polynomial. What is a polynomial definition? An algebraic expression with a whole number as an exponent of the variable is called polynomial. For example, I will show you one expression here. 2x plus 3. Here what is the power of the x? 1. 1 is whole number. So it is algebraic expression because variable. What they are saying, an algebraic expression with the whole number as the exponent. Exponent meaning is power of the variable. Exponent means power. You can write power of the variable also here. Power of the variable is called polynomial. Whole number as a power. Power should be whole number. Whole numbers means what? Numbers which will start from 0 are called as a whole numbers. Means their fractions and negative numbers will not come in the whole numbers. Always in the polynomial, in the algebraic expression, this variable should contain whole number as a power. Then only we can call this algebraic expression as a polynomial. Okay. For example, in one more expression I will write 2x to the power of 2 by 3 plus 2. This is not a polynomial. Why it is not a polynomial? Because here x to the power of 2 by 3, it is not a whole number. Here variable power should be whole number. Then only we can say it is a polynomial. This definition you already learned last year, and this is a starting definition of this chapter. An algebraic expression with a whole number as an exponent of the variable is called a polynomial. In your classwork, first you start the heading polynomials and definition you write. An algebraic expression with a whole number as a power or exponent of the variable is called a polynomial. And you learnt about the coefficients last year. Here what is the coefficient of x? 2 is a coefficient. Before x, what is that? That is a coefficient of a x. And I will show you some more examples which are the polynomials, which are not polynomials. I will show you some examples. 2y plus 3 plus 6x. This is a polynomial. Here how many variables are there? 2 variables are there. What is the coefficient of x here? Coefficient of x is 6 here. Before x, what is the coefficient of y? 2. What is the coefficient here? Nothing is there, just you can't. Variable coefficient. Before variable, what is there? Just you have to see. Suppose if I write like this, x plus 3y plus z. What is the coefficient of x? Nothing is there means 1 will be. Coefficient of x will be 1 here. Suppose if they give the expression like that, minus x plus 2y plus z. What is the coefficient of x here? Nothing is there means minus 1. So coefficient of x will be, x is minus 1. Like this we will take. We will learn already about the coefficients also. And now in this chapter newly we are going to learn about the polynomial. This is the definition of the polynomial, and you've already learned that, and you are going to learn about the degree of the polynomial. You understood what is the difference between the polynomial, not a polynomial. This is not a polynomial. Suppose variable is containing the power as a fraction or negative number. Sometimes they will give like this also examples. Just I will show you. X plus 1 by x. This is not a polynomial, because if you write in this in the standard form, x plus, if I write this, if I take this to numerator, this will become x to the power of minus 1. So it is not a polynomial. It is not a polynomial like this. Okay, don't get confused which is polynomial, which is not a polynomial. You should correctly identify it. Okay, in your textbook, some of the examples they have given, just you see those examples and then you can understand easily. Then suppose sometimes if they will give like this, 1 by x, sorry, 1 by x I have given already, root 3 plus x. This is a polynomial because here 3 is not a variable. This is a polynomial. Because always we should see the power of the variable, not power of the number. Suppose if they give x plus 3, this is not a polynomial. Try to understand this. This is not a polynomial. Okay, and in this chapter you are going to learn definition of the polynomial I told you, and next we are going to learn about the degree of the polynomial. Degree of the polynomial we are going to learn. Degree means degree of the polynomial. Degree of the polynomial means highest power of the variable in the algebraic expression is called as a degree of the polynomial. Degree of the polynomial means the highest power of the variable in the polynomial is called as a degree of the polynomial. For example, I will show you some sums here. Some examples I will take. X to the power of 4 minus x to the power of 5 plus 3. Here what is the degree of the, what is the higher power of the x? 4 is there. Here power of the x is 5 is there. Which is the highest number here? Degree, highest degree is 5. So degree of this polynomial is, degree is 5. Always degree means highest power of the variable in the polynomial. This is a polynomial. Polynomial can contain infinitely many terms. Polynomial can contain one term. Polynomial can contain 2 terms, 3 terms, 4 terms, 5 terms, like that. Infinitely many terms it can contain. So here it is containing 3 terms and highest power of the variable is 5. So it is called as a degree of the polynomial. So degree of the polynomial definition is highest power of the variable in the polynomial is called as the degree of the polynomial. One more example I will show you and tell you. 2 minus y square minus y cube plus 2y to the power of 4. Here variable is y cube, y to the power of 4 is there. Just you see which is the highest power here, 4. So degree is 4 here. Like this we will take the degree of the polynomial. And based on these degrees, we are going to learn the types of the polynomials. Those are, first one is linear polynomial. First one is linear polynomial. Just I will tell you what is a linear polynomial. Linear polynomial means degree should be, degree is 1 means that is called as a linear. For example, 2x plus 3. Here power of x is 1. So degree is 1 means this is called as a linear polynomial. Degree of the polynomial is 2 means it is called as a quadratic polynomial. If the degree is 3 means it is called as a cubic polynomial. Degree means you can understand. Highest power of the polynomial should be 3. That is called as a cubic polynomial. And I will give the definitions clearly about it. Next, you should be knowing how many variables will be there in the polynomials. Usually, one variable only we are going to learn in this chapter. And a polynomial containing only one variable we will learn. In the higher classes, you are going to learn more than one variable in the polynomials. Now we are going to learn only one variable with the polynomials. And polynomials are represented by p of x. For example, variable in the expression is x means that is represented by p of x. Suppose 3x plus 2. This polynomial is represented by the letter polynomial with the variable x. We can use q of x also, no problem. 7x square plus 7x plus 3. Here also variable is x, so we can use q of x. Any letters we can use here, but which is a variable is there in the expression that we can use. Suppose if the expression is like this, 2y plus 7 is there means you can use this p of y because here variable is y. So we can use the P of y, or you can use Q of y also for this, or R of y also, R of Q of y, R of y also we can use it. Q, small letters we will use, P of Q, P of y, Q of y, R of y, R of y, 2y plus 7, like this, 2y plus 6. If you want to represent more more polynomials by the same variable, we can differentiate by these letters. P, Q are different. Suppose here 8 I will take, this is 9 I will take. These three are the different polynomials, so we can use P of y, Q of y and R of y, like this we can use. But here variable is same, but polynomials are different, so to represent like that, P, Q, R we can use it. Like this we will represent the polynomials. Okay, this is the introduction. Just we will see what you have to write in the classwork now. See here, first you should, in the classwork, first you should write the definition, polynomial heading, then you write the definition. An algebraic expression with the whole number as an exponent or power of the variable is called polynomial. First you write this definition, and I have written the examples here for the polynomials. X square plus 2x is a polynomial in x. Here variable is x, and what is the degree of this polynomial? Here see, degree is, power is 2 means degree of this polynomial is 2, and it is called as a quadratic polynomial. I already told you, a polynomial with a degree 2 is called as a quadratic polynomial. So, and it is denoted by P of x because variable is x here, so we used P of x. This is example 1. Example 2 is 3y square plus 5y equal to, 5y is a polynomial in y and is denoted by P of y equal to 3y square plus 5y. Third one is t square plus 4. Here variable is t, so we used P of t square plus 4. Next I have written one note here, just you write this. If the variable in the polynomial in x, we may denote the polynomial by P of x or Q of x or R of x. I already told you how to represent the polynomials. P of x, variable is x means here variable y is there, here variable x is there, so we used, here see, here also variable x is there, here also we used x is there. Here we used P of x, Q of x to differentiate this, and here variable is u is there, so s of u we used. Just you write this note and you should remember this, how to represent the polynomials. Next, second point of the note is, a polynomial can have infinite number of terms. I already told you, it can contain one term, two term. One term it is containing means it is called as a monomial. It is like algebraic expression. An algebraic expression and a polynomial containing one term means it is called as a monomial. If it is containing two terms means binomial. If it is containing three terms means trinomial, like algebraic expression only. So here it is can contain infinitely many terms. It is containing 151 terms. This is up to here 150. This is 151 terms. And next, degree of the polynomial. I already told you, the highest power of the variable in the polynomial is called as a degree of the polynomial. Write this definition. And I already told you about the linear polynomial. A polynomial of a degree 1 is called as a linear polynomial. And here general form is, this is very important. General form of the linear polynomial is ax plus b, where a and b are, I told you already, if you in place of constant you are using alphabets means we will write there where a and b are the constants, and a is not equal to 0. Why I have written a is not equal to 0? Linear polynomial means variable power should be 1. If it is 0, x also will become 0. That time power will be 0 will become. So 0 into x will become 0 there. Power of the x will become 0 there. So this is linear polynomial. If you want means a should not be equal to 0 here. Similarly, quadratic polynomial. A polynomial of a degree 2 is called as a quadratic polynomial. This is general form, ax square plus bx plus c. Here a should not be equal to 0. B can be 0, c can be 0, but a should not be equal to 0 because quadratic polynomial, if you want, degree should be 2 there. Next we will see cubic polynomial. Cubic polynomial is also a polynomial of degree 3 is called a cubic polynomial. General form of the cubic polynomial is ax cube plus bx square plus cx plus d. Here also a should not be equal to 0. Here a, b, c, d are the constants. Next, a polynomial of degree n. Like that only we can take degree n also. A polynomial of one variable x of a degree n is called an degree n is an algebraic expression of the form. Like this it will be a n x to the power of n plus These and all we'll learn in the higher classes. Here a0, a1, a2, an are the constants. Okay, this is the introduction about the polynomial. In the next video we are going to start the first exercise of this chapter. If you like this video, please like, share and subscribe my channel. Thank you.